Hi, I am Arib. You are watching my YouTube channel. I hope you all are doing well and are happy and safe, including your families. Welcome to my YouTube channel HAH Electrical. Today, we will discuss the topic about BusBar. It is necessary. Let's start the topic. Before that, subscribe and like my channel and press the bell icon so that you can receive every new video. BusBar. BusBar scheme in grid station. Definition of BusBar. Electric busbar or simply busbar is solid rectangular strip or bars which is used for collecting electric current from incoming terminals and to distribution them among outgoing terminals of the system. It is also defined as junction between the incoming source and outgoing terminals of the system. The shape of strip or bar may be other than rectangular size like round tubes, round bars or of square shape. In general, aluminium or copper material is used for the bar or strips. Aluminium is used over copper because of numerous advantages like low cost, corrosion resistivity, etc. Copper strip or bars are used where the high magnitude of the current is flowing through conductors. The electrical bus bar sizes generally used in the system are 40 by 4 mm, 160 mm to 40 by 5 mm, 200 mm to 50 by 6 mm, 300 mm to 60 by 8 mm, 480 mm to 80 by 8 mm, 640 mm to and 100 by 10 mm, 1000 mm to. There are many types of electrical bus bar according to the applications. There are some points to be considered while selecting an electrical bus bar type, such as simple design as per requirement. There should be provision for maintenance without interrupting the power supply. If the load on system increases, then there should be scope for extension. Installation should be cheap. Types of electrical bus bar system. Single bus bar scheme. Single bus bar arrangement is the basic and easiest design, consisting of a single group of bus bar or strip. This set of bus bar connects all the components present in the system such as generators, transformer and feeders, etc. The circuit breakers keep eye on each generator and feeder. The isolators are used for isolation of generators, feeders and circuit breakers from the bus bar when we keep out it for maintenance. Advantages of single bus bar scheme: low initial cost, simple and easy to operate. The maintenance requirement is low. Disadvantages of single bus bar scheme: if a fault occurs on a bus bar, the whole system gets affected, while in case of maintenance of the bus bar, supply gets interrupted. This design is not flexible for a large power system. Single bus bar scheme with bus sectionalizing. Name itself explain that bus bar is sectionalized by a circuit breaker and isolating switches. This arrangement does not lead complete blackout. If a fault occurs on any system, this method of sectionalizing the bus bar is used in large generating stations where several units are installed. Advantages: if a fault occurs on any section of the bus bar, it can be isolated by isolators without affecting the existing system and other sections. One section can be completely shut down for maintenance and repairs without affecting the supply of the other section. By adding a current limiting reactor between sections, the fault level can be reduced. Thereby, circuit breakers of lower capacity can be used. Main and transfer bus bar scheme. Main and transfer bus arrangement have two buses, namely main bus and transfer bus or auxiliary bus bar. This kind of arrangement is suitable for a system where the power system is interconnected with so many connections, and flexibility are a very important issue. This arrangement has flexibility, continuity of supply, and we can allow maintenance after some interval of time without total blackout. This combination of main and transfer bus has been used where we need the loads and continuity of supply for normal working condition. The main bus bar is in operation while maintenance of the main bus bar, the transfer bus bar, is in operation. In this arrangement, a bus coupler is usually used so that changes the connection from one bus bar to the other bus bar. Advantages of main and transfer bus bar system. If a fault occurs on any one bus, then we can transfer the load to other bus without disturbing the continuity of supply. Maintenance of other components like feeder circuit breaker can be carried by putting them on an additional bus and keeping the main bus in operation. Substation maintenance is cheaper. The bus potential can be used for relays. Maintenance of the main bus can be carried by transferring the entire load on the auxiliary bus bar. Disadvantages of main and transfer bus bar system. As additional bus added to the system, then the overall cost of system increases. After transferring all circuit from the main bus to auxiliary bus, if a fault occurs on any circuit in load may cause a complete shutdown. Double bus double breaker scheme. This system is quite similar to the previous one, but the only difference is that every circuit is provided with two circuit breakers and bus couplers are not used. It fulfills the deficiency of previous electrical bus bar system. We can transfer the load from one bus to the other whenever desired without interruption. This arrangement provides the advantage of maximum flexibility and reliability because the interruption of supply due to the faults and maintenance is minimum. A circuit breaker can be taken out for maintenance and repair. The load can be shifted on the other circuit breaker easily. This system has a disadvantage of very high operational cost and maintenance cost. Sectionalized double bus scheme. In this arrangement, the main bus bar is sectionalized into two bus bar in which one of them is duplicate bus bar and the other is the main bus bar. These two bus bars separated by bus coupler arrangement. Since only one circuit breaker is used for one circuit, the cost of a system decreases comparatively. In this arrangement, any section of the bus bar can be isolated for maintenance while any section may be synchronized with any other through the auxiliary bus bar. Here only the main bus bar is sectionalized while transfer bus bar is used as it is. 1.5 breaker scheme. The name itself indicates that 1.5 circuit breaker is used for one circuit. It means two circuit breakers are used for 3 circuits. This arrangement fulfills all deficiency in double bus double breaker arrangement and it affects saving in the number of circuit breakers. This arrangement is used in an important large interconnected power system where power handled per circuit is large. This arrangement has been used in modern EHV 400 kV and UHV 750 kV substation. Advantages. This arrangement provides guaranteed continuity of supply as a fault in a bus or in a breaker will not interrupt the supply. There is scope for expansion of circuit to the system. The bus potential can be used as a supply to relays. Disadvantages. When a fault occurs on the system, two breakers are to be opened, which leads to complication in relaying system. High maintenance cost. In case of maintenance of breakers, we have to go for load shading. If we don't go for load shading, then two breakers are open and other circuit. Ring bus bar scheme. In ring bus system, two bus bars are coupled with the help of bus coupler, and one of them is sectionalized to from ring type structure. Each feeder is supplied from two sides, so if any one side failed to supply, the other side supply maintains continuity of supply. Hence, high flexibility of the system is achieved. Again, if any system gets failed, then there is an option for maintaining supply continuity. The effect of fault in one section is limited to that section only. The rest of the sections continue to operate normally. We can take circuit breakers for maintenance and repair without interrupting the supply. Please comment how you like my video. Thank you for watching my video.